Jai Hind students, welcome to my YouTube channel. Students, I am very hopeful that you must be studying on consistent basis and you're working real hard, isn't it? Students, I will start this session with the sayings that life is not about being rich, being popular, being highly educated or being perfect. Life is about being real, being humble, being kind, and most importantly, life is all about being a good human being, right? So do concentrate on becoming a good human being, right students? So with that, let's start today's session. As per promise, I have come up with some more interesting questions related to friction. So in this session, we are going to attempt these 5 questions, right? So let's start with the first one. Okay, first question is students, it is a system comprising of 2 blocks of masses M1 and M2, right? This is a pulley which is fixed, massless and frictionless, and this is a string which connects these 2 bodies, and body of mass M1 is placed on a horizontal surface. And this string makes an angle theta with the horizontal. It is given that this system is at equilibrium, right? We are supposed to find out the coefficient of static friction between the surfaces of these 2 bodies. So our objective is to determine the expression for the coefficient of friction between these 2 bodies in contact, right? Now the key point is the system is at equilibrium. So the net force acting on this body is 0, net force acting on this body is also 0. So we can easily solve it by constructing the free body diagram and then using the equations, right? So let's draw the free body diagram for M1, right? So diagram is like this. This is the body of mass M1. What are the forces acting on it? One naturally would be its weight, M1g. The other is the reaction which the horizontal surface will exert on the block in the upward direction. And this is tension, students. This is the tension. Tension, as I told you, it's a force which acts along the length of the string towards the point of suspension, isn't it? So this T can be resolved into 2 components. Along this component, along the horizontal, it will be T cos theta, isn't it? This T along this component, it would be equal to T cos theta, while in the vertical direction this component would be T sin theta. So let us represent it over here. So this component is T sin theta. Clear, students? Now under the influence of component T cos theta, the block will tend to slide along this direction towards right, and that being provided or that being prevented by the force of friction, which will act in the opposite direction. Clear? So the body will tend to move along this direction. So the force of friction will always act in a direction tangential to the surfaces in contact and in a direction opposite to which the body tends to move. So force of friction will act towards left. The body will tend to move towards right. Okay. Now the net force acting on this body is 0. Therefore, net upward force is 0. Therefore, net upward force R plus T sin theta, it should be exactly balanced by the net downward force. That is, R is equal to M1g minus T sin theta. Isn't it? Also, net force along the horizontal direction is also 0. So, frictional force must be equal to T cos theta, right? Now, F is equal to mu R as per the law of friction. So, mu R, substitute the value of F as mu R. You can substitute this value of R over here. So, what you get is mu. In place of R, you can write M1g minus T sin theta. It is equal to T cos theta. Students, put this as equation number 1, right? Now let's draw the free body diagram for the body of mass M2. We can draw the diagram over here only. So this is the weight of the body, M2g. These are the only 2 forces acting on body of mass M2. Now since this body is at equilibrium, Therefore, it must be under the influence of balanced forces. Therefore, T must be equal to M2G. So, for M2, the equation will T, it will be equal to M2G. So students, simply substitute this value of T as M2G over here, and then we can easily solve for the expression for coefficient of static friction, right? Therefore, from 1 and 2, what we get is mu M1G minus, in place of T you can write M2G sin theta is equal to, in place of T you have to substitute by M2G cos theta. Therefore, the coefficient of static friction, it will be equal to, G is common, so it gets cancelled out. So M2 cos theta divided by M1 minus M2 sin theta. So this is the expression for the coefficient of static friction in terms of M1, M2 and theta. Right? So I hope you have understood this particular question. Simply students, as was done previously, you need to draw the free body diagram and then construct the equations using Newton's second law. And the only additional force acting over here would be the frictional force. The surface is in contact. It is given that the coefficient of static friction to be mu, and its expression is to be found. Right? That is what we have done over here. So students, we are over with question number 1 then. Right? This is the complete solution. Let's concentrate on the next question then. The second question is actually similar to that of the first one. In the second question, a body of mass m is given and it is under the influence of two forces, force P acting horizontally and force Q acting obliquely, making an angle theta with the vertical. Force Q is making an angle theta with the vertical, right? And it is given that the system is at equilibrium. So we are supposed to find out the expression for the coefficient of static friction, right? The body is at rest and under the influence of these two forces the body remains at rest. So the body is at equilibrium. Okay. So let's draw the free body diagram then. This is the block under consideration. This is suppose the center of mass, that is, it's a hypothetical point where the entire mass of the body may be assumed to be concentrated, right? So let's indicate all the forces over here. This is the force P. It is acting along this direction, right? Along this direction, towards right. So at this point, force P would be along this. This is force P. Q is acting along this direction, like this. It is acting along this direction. So, Q, this is force Q, acting along this direction. And this is the vertical. Now students, look. If we draw vertical over here, then this angle would be obviously equal to this angle. Being vertically opposite angle, isn't it? This is also theta. These are the vertically opposite angles. So, this angle is theta. Q is acting along this direction, like this, making an angle theta with the vertical. This is the angle. This is angle theta. So, these are the vertically opposite angles. Clear? What are the other forces acting on this body? One will be its weight will act in the vertically downward direction. The other one is the reaction force, which the ground or the floor will exert on the body in the upward direction. The reaction force, it always acts perpendicular to the surfaces in contact. So, these are the forces acting on it. And the body will tend to move along this direction. So, force of friction will act along this direction, in the direction opposite to which the body tends to move, right? And it is given the body is at equilibrium. So the body is under the influence of balanced forces, right? So let's consider the equation. Now, Q, it can be resolved into two components, isn't it? This component would be Q cos theta. Q is resolved into two components. This is Q cos theta and this component, students, it will be Q sine theta. Right? Now, the net force acting in the vertical direction is 0, and that is possible only when R, the net upward force, is balanced by the net downward force. Net downward force is mg plus q cos theta. Put this as equation number 1. Right? Net force acting on the body along the horizontal direction is also 0. So net force acting towards left must be equal to the net force acting on the body towards right. That is P plus Q sine theta. Also, we are aware, students, F is equal to mu R. Mu is the coefficient of static friction, whose expression is to be determined. Right? So, making use of these three, what we get is, using equation 2, we get F is equal to mu R. We are using equation 2. So it is equal to P plus Q sine theta. So mu, substitute this value of R from equation 1. What do we get? mg plus Q cos theta. It is equal to P plus Q sine theta. Therefore, students, the coefficient of the static friction, it will be equal to P plus Q sine theta divided by mg plus Q cos theta. So this is the expression for the coefficient of static friction. Right? So simply you need to draw the vector diagram, you need to resolve Q into two perpendicular components, and the body being at equilibrium, it is understood that the body is under the influence of balanced forces. So that is how we have constructed these equations, and then rearrange the terms, we can easily find the expression for mu. So it is P plus Q sine theta divided by mg plus Q cos theta. Right? This is the answer. This is the expression for the coefficient of static friction. So students, we are over with question number 2 as well. Right? Let's proceed with the third question, which is very important one. This is very important one. Let me put an asterisk symbol for you. So, let me read the question for you. Question number 3. A body of mass m rests on a horizontal floor with coefficient of friction mu. Coefficient of friction is given to be mu. It is desired to make the body move by applying the minimum possible force. We are supposed to find the magnitude of the force and the direction in which the force is to be applied. Right? Again I repeat. A body of mass capital M rests on a horizontal floor with coefficient of friction mu. It is desired to make the body move by applying minimum possible force. So we are supposed to find out the expression for that minimum force and the angle or the direction in which that minimum force is to be applied on the body, so as to make it move. Right? So let us draw the diagram first. So this is the horizontal surface and this is the block, suppose. Right? It's of mass m. Its weight, obviously mg will act along this direction. Reaction, it will be in the upward direction perpendicular to the surfaces in contact. Let us consider F is the minimum force which is to be required to be applied on this block so as to make it move. Right? And suppose this force F is applied in a direction making the angle theta with the horizontal. Right? So F can be resolved into two components. This component would be F cos theta and this component would be F sin theta. Right? So the body will tend to move along this direction. So the force of friction will naturally act in the opposite direction. Actually, force of friction will act along the surfaces in contact tangentially. So I have drawn an equal vector at this particular point. So this is the force of friction. So this is the diagram, students. So the body is on the verge of motion. The body just begins to move. So at that instant the body may be considered to be under the influence of balanced forces. Just at that moment, the body is on the verge of motion, right? So considering the body to be under the influence of balanced forces, what we get is, in the vertical direction, r plus f sine theta, it will be equal to mg, or reaction force, it will be equal to mg minus f sine theta, right? Okay, along the horizontal direction, it will be f cos theta is equal to f. Small f is the force of friction, and that we are aware as per the law of friction is equal to mu r. Mu is the coefficient of the static friction, right? So, substitute this value, put this as equation 2. Mu, substitute this value of r from equation 1. What do we get is mg minus f sine theta. Let us try to rearrange the terms. What we get is f can be taken as common, cos theta. If you take this mu f sine theta over here, f is common over here. So it will be plus mu sine theta is equal to mu mg, isn't it? Therefore, f is equal to mu mg divided by cos theta plus mu sine theta. Put this as equation 3. Clear, students? So basically, what we have done is, since under the influence of this minimum force, the body just begins to move. Since the body is assumed to be on the verge of motion, therefore, the body can be considered to be under the influence of balanced forces. So that is how I have constructed these equations, right? Now here, for f to be minimum, the term in the denominator, that is cos theta plus mu sine theta, it must be maximum. So, we need to find out the expression for the minimum force that needs to be applied to the block so as to make it move, isn't it? Now for f to be minimum, this denominator needs to be maximum. Numerator is constant, isn't it? Mu is the coefficient of static friction, which for given two surfaces is constant. M is constant, G at a given place is constant. So for f to be minimum, the denominator, that is cos theta plus mu sine theta, it must be maximum. And students, we have already done in mathematical tools, for the maximizing condition, the first derivative, it should be equated to 0. Actually, at the end of this session, in the description of this episode, I will share the link of the lecture in which we have discussed the maximizing condition. You can refer to that in case of any doubt, right? So, therefore, the differentiation of this with respect to some variable, here theta is the variable, in which direction this force is to be applied, right? So theta is variable. So differentiation, first derivative of this term must be equal to 0. So students, for f to be minimum, the denominator should be maximum, and for the denominator to be maximum, the differentiation of the denominator should be equated to 0, right? So what we get is differentiation of cos theta with respect to theta, it is minus sine theta, plus mu is constant. Differentiation of sine theta with respect to theta is cos theta. So what we get is mu cos theta is equal to sine theta, or sine theta by cos theta, that is tan theta is equal to mu. Therefore students, theta is equal to tan inverse mu. So we have found the direction in which the force is to be applied so as to make the block move. And what is the direction? The minimum force should make an angle theta with the horizontal, where theta is tan inverse mu. So this is the direction of this minimum force which is to be applied on the block, right? So as to make it move. So one of the part of this question is done, right? Now let's find out the magnitude of F minimum, right? Let us find out the magnitude of F minimum. So for that, what we do is, we need to substitute this value of cos theta and sin theta from here and then get the expression for F. Okay, let's do it. So, this is the expression for F, isn't it? And for F to be minimum, the denominator, it should be maximum, isn't it? Now, we are aware of the value of tan theta. We can make use of this triangle. This is theta. Tan theta is perpendicular by base, isn't it? It's mu by 1. So, perpendicular is mu, base is 1. So, tan theta is equal to perpendicular by base. Am I clear? So, this is base, this is perpendicular. So, what about hypotenuse? It would be square root of mu square plus 1. Therefore, students, sin theta, we require sin theta and cos theta. Sin theta would be perpendicular by hypotenuse, that is mu divided by square root of mu square plus 1. And cos theta would be base over hypotenuse, that is 1 divided by square root of mu square plus 1. Right? So we obtained both the values of sin theta and cos theta. Now let's find out F minimum. So it is equal to mu mg divided by cos theta. Cos theta is 1 over square root of mu square plus 1 plus mu sin theta plus mu sin theta. So mu into mu, that will give us mu square divided by square root of mu square plus 1. Right? So this can be rearranged. It will be equal to mu mg. So it will be square root of mu square plus 1 divided by, if you take mu square plus 1 as LCM over here, so here we will be left with 1 plus mu square. So it can be further arranged in this manner. Mu mg divided by 1 plus mu square. It can be written as square root of mu square plus 1 multiplied by square root of mu square plus 1. So square root of mu square plus 1, square root of mu square plus 1 get cancelled out. So we are left with mu mg divided by square root of 1 plus mu square. So students, this is the minimum force which needs to be applied on the block at an angle theta, making an angle with the horizontal, where theta is tan inverse mu. Theta is tan inverse mu, so as to make the block move. So we have found both magnitude as well as direction. Right, students? So we are over with question number 3 as well. This is a very, very interesting and very good question. Right? Okay, students, now let's proceed with question number 4. It's a very, very interesting question. It's given that if the coefficient of friction between an insect and the surface of the bowl is mu, then we are supposed to find out the maximum height which the insect can crawl in the bowl. Right? And the radius of the bowl is given to be smaller. So we need to express the maximum height up to which the insect can crawl, that is h, in terms of r. So let us draw the diagram first, right? Without diagram, this question can't be solved, obviously. So in physics, wherever applicable, it is absolutely mandatory to draw the relevant diagram, right? Okay, this is a bowl, suppose, and let us consider its radius to be r. This is the center, and its radius is r. It's given in the question. Its radius is small, so the answer is to be expressed in terms of r only. Right? And suppose the insect can crawl up to a maximum distance over here. So it has gained height h. Suppose it has gained height h. So our objective is to find out the expression for this height which the insect can gain or can crawl up to inside the bowl. So if this is h, then the remaining distance would be r minus h, obviously, isn't it? Now draw a line over here. This will act as the radius any point from the center to the circumference, that will give you the measure of the radius, right? Let us consider this to be angle theta. Let us consider this to be angle theta. Now students, we will represent the forces acting on the insect, right? What are the forces acting on the insect? One will be its weight, which will act in the vertically downward direction. The other would be the reaction force, which the surface of the bowl will exert on the insect in the perpendicular direction, right? So one is its weight, it will be along this direction. If the mass of the insect is m, then the weight of the insect would be mg in the vertically downward direction. Reaction force, it will be perpendicular, that is along the radius towards the center. This is the normal force. Let us represent it by capital letter R. Capital R is the normal force. Now students, this mg, it can be resolved into two components, isn't it? So these are the two parallel lines. This will act as a transversal. So this angle would be equal to this angle. Pair of corresponding angles, right? So mg can be resolved into two components. This component would be mg cos theta. This component is mg cos theta. While this component, it will be equal to mg sin theta. So the component mg sin theta will make the insect to come back to its original position, isn't it? But the force of friction will act in the opposite direction. This is the force of friction, which acts tangentially, that is parallel to the surfaces in contact, and in a direction opposite to which the body tends to move. The insect will tend to slide along this direction, so the force of friction will act along that direction, right? So on reaching this position, suppose the insect is at rest. It's the maximum height which the insect can gain, right? So students, now let's construct the equations then. So F, it should be equal to mg sin theta, while the normal reaction force, it should be equal to mg cos theta. So therefore, F, it is equal to mg sin theta, while R would be equal to mg cos theta. Okay, F is equal to mg sin theta and R, it is equal to mg cos theta. So if you divide these two, what do you get? F by R is equal to mg get cancelled. Sin theta by cos theta is tan theta. Also students, F by R, we are aware the ratio of the frictional force to the normal reaction force is known as the coefficient of friction. So we are aware of this. Therefore combining these two, we get tan theta is equal to mu, right? Put this as equation number. So students, tan theta is equal to mu. Actually, in the question, the value of coefficient of the friction, it's given to be 1 by root 3, right? It is only then we can find out the expression of h in terms of r. So students, in the question, the coefficient of the friction is given to be 1 by root 3. So let's substitute this value. So since mu is given to be 1 by root 3, it's given in the question itself. So therefore, tan theta is equal to 1 by root 3, which implies that theta is equal to 30 degrees. Clear students? Once we have obtained the value of theta, now we can easily find out the expression for h in terms of r. So we need to find out the expression for h. So consider this triangle and consider cos theta over here. So cos theta, theta is 30 degrees. Cos 30 students, it's equal to base over hypotenuse. Base is r minus h and hypotenuse is r. So cos 30, we are aware, cos 30 is root 3 by 2. So root 3 by 2 is equal to r minus h by r. So let's solve it. On cross multiplication, we get root 3r is equal to 2r minus 2h. So therefore, 2h, it will be equal to 2r minus root 3r, or H would be equal to R minus root 3 by 2R. Let's solve it further. So what do you get? R minus 1.732 divided by 2 into R. That will further give us 0.866 R. So therefore students, the maximum height up to which the insect can crawl in the bowl is 0.134 R. Right? So this is the answer. So this is the maximum height up to which the insect can crawl on the surface of the bowl. So this was a very, very interesting question. So we are done with question number 4 as well. Now let's try to attempt question number 5 then. Now concentrate on the diagram given in question number 5. It's a system comprising of two bodies A and B, each of mass small m. So here the coefficient of friction between the horizontal surface and body A is given to be 0.2. We are supposed to find out the acceleration of the system, right? Mu is given to be 0.2 over here, right? So acceleration, suppose it's along this direction, obviously. So these two bodies are connected by a string over a fixed pulley. So in a given time, both the bodies will cover same distance. So both the bodies constituting the system will possess same acceleration. So if its acceleration is downward, its acceleration will be horizontal towards right. Okay, let's draw the free body diagram for body A. Okay, this is it. This is body A. What are the forces acting? One is its weight, the other one is the tension, which obviously acts along the length of the string towards the point of suspension, right? So this is where the tension acts. This is the normal reaction, and this is the acceleration. The body tends to move along that direction. It is moving along that direction actually. So force of friction being opposing nature, it will act in a direction opposite to which the body moves. So obviously no net forces in acting in the vertical direction. So R should be equal to mg, and T is dominating as compared to frictional force. That is why the body is getting accelerated along the direction of the tension, right? So what is the net force acting over here? It is T minus F. This is the net force acting on it, and as per Newton's second law, net force is mass into acceleration. Its mass is m, acceleration is k. So T minus F, we are aware it's equal to mu R. So that will give us T minus mu, R is mg, is equal to ma. So this is equation number 1, right? Now let's draw the free body diagram for body B. For body B. Okay. The only forces acting on body B are, one is its weight and the other one is tension in the string. And the body is getting accelerated downwards. So equation would be mg minus T, right? Mg minus T is equal to ma. So we need to find out the value of A. So tension is to be eliminated. So consider these two equations. Equation 1 contains term capital T, equation 2 contains term minus T. So the tension can be eliminated by adding equation 1 and 2, right? So adding these two equations, what we get is T minus T get cancelled. Over here it's mg minus mu mg. It is equal to ma plus ma. So that will give us twice ma. So m on both the sides will get cancelled out. So we are left with g minus mu g is equal to twice a. Right? So let's substitute the values then. So therefore A is equal to 1 minus mu divided by 2 into g. So 1 minus, let's substitute the values. mu, the coefficient of friction, is given to be 0.2. In this case, it must be the coefficient of kinetic friction. So it is 0.2 divided by 2 into, let's consider the value of small g to be 10 meter per second square. So acceleration, it will be equal to 0.8 multiplied by 5. So it will be equal to 4 meter per second square. So that's the answer. So the acceleration of the system of each of the bodies is 4 meter per second square. So students, I hope you have understood these questions, right? Do practice as many numericals as you can. It is only through practice that you can gain in confidence, right? So that's it for this particular session. Do join me in my next lecture then, right? Till then, bye-bye, and do take very good care of yourself. Thank you.